Welcome back to the session on probability distribution function. In this particular session, we are going to look about what defines the probability distribution, what are discrete and continuous random variables, what is probability mass function and cumulative function of discrete random variables, probability density function and cumulative distribution function of a continuous random variable. Without delay, let us go and understand the definition of probability distribution. Now, probability distribution is a mathematical division of the probabilities of events, subsets of a sample space. So, whenever we are dealing with sample, the sample is drawn out of the population, and a small part of the population is called as sample. Now, the moment you take up the sample, what is the probability that that particular event is going to occur is being stated as the probability distribution in a mathematical format. Now, when the sample size is drawn, it can be either in numeric format or a non-numeric format. Now, what do I mean this? Tossing of a coin. Let us take the example of tossing of a coin. The moment you toss a coin, what is the probability that it is going to give you a head on the first chance? Right? So the distribution of number of times heads occurring during the 20 times of tossing a coin is called as the probability distribution. If at all, if you are going to represent the tossing of a coin as a function of a mathematical statement, that means the moment I toss a coin for the first time, the x is equal to first time. So if it is heads, now x is equal to 2 times. The moment you toss a coin, it is heads and tails. The moment you are going to toss it for the third time, it is heads, tails, and tails. So like this, what we are going to do, we are going to capture the outcome of the events, right? So out of the 20 times of tossing a coin, if at all, if you are checking within the 3 times, the very first 3 times, what is the chance of occurring of a head, right? Then that is called as a sample. And the outcome, which is a function of this particular mathematical statement, is called as a probability distribution. Now, going ahead with this, when I said that the probability distribution or the outcome of a variable can be numeric or non-numeric in nature. For example, let us assume a bank want to find it out whether the transaction is a fraudulent transaction or non-fraudulent transaction. In such a case scenario, the outcome of your variable will be either fraud or non-fraud. That is what defines whether it is numeric or non-numeric. If a bank wants to know the number of fraudulent transactions than the actual sequence of occurrence of the fraudulent transaction, then it is also being termed to be a non-numeric. Now, for this, in order to find this outcome variable, your outcome variable has to be measured. So whether it is a fraud or non-fraudulent, then how many times the occurrence of the sequence of a fraudulent transaction when you look at the genuine transactions, right? Now, if you just see here, you need some sort of measurement to be done. Now, that measurement of the outcome variable is being called as the random variable. Hence, variable that is used to define the function that maps the outcome to a real number is called as random variable. Hence, the definition of the random variable is a function that assigns a real number to each sample point in the sample space S. So that means if I just take a sample space of 20 times tossing a coin, out of 20 times, how many times heads has appeared and how many times the tails has appeared. This is numeric in nature because I am making, the number of times. Right? If I'm going to take the sequence, heads, tails, heads. Now, in this particular transaction, I wanted to know, or this particular trials, I wanted to know what is the chance that at least there is one tail. Right? At least there is a chance of occurrence of an event for at least 1. Right? So this is non-numeric because I have a sequence of this particular events. Right? So here I'm not taking number of times. I'm taking at least 1 time. So when I toss a coin for 3 times, at least 1 time it should be at least 1 time it should be a time. Right? So if you see here, I'm taking a sequence of the events over here. That defines numeric and non-numeric. In the further session, we are going to discuss in detail about how to measure these random variables and what are these random variables are called if they are numeric in nature or non-numeric in nature. Thank you all. Thank you everyone. Till then, happy learning. See you in the next session. Discussed about the type of random variable. The outcome variable can be numeric or non-numeric in nature. Based on the nature of the variable, the type of random variables are being divided into 2. The first is the discrete random variable and the second is the continuous random variable. Now coming to the understanding of what do discrete and continuous random variable mean. So discrete random variable, if a random variable x can assume only finite values, then it is being termed as discrete random variable. For example, let's assume that a credit agency or a bank wanted to understand what is the credit rating of the customer and they wanted to classify the customers based on different levels. In that, they are saying that if the credit level or the credit rating or the CIBIL rating is low, then they wanted to mention it as a low customers, low risk customer. I don't say it as low risk, low customers, or a medium customer or a high customer. Now, if you see here, you have a definite outcomes here. Either he will fall into low, or he will fall into medium, or he will fall into high. Now, if you just look at the second example of customer churn, whether a customer will churn or do not churn, whether a software will functioning faster, will not be functioning faster. Hence, if you see here, your outcome is finite. Your outcome is finite to 2 options, or your outcome is finite to 3 options, right? So hence, all the classification problems are examples of discrete random variables. Now, having the understanding of discrete random variables, now let us go ahead and understand what are continuous random variables. A random variable X is said to be continuous if it takes infinite set of values. That means there is no finite value here. Earlier in the discrete random variable, what did we do? Whether a customer will churn or will not churn. So there exactly you had only 2 cases over there for the outcome variable. Right? Whereas in the continuous random variable, you will be not seeing that. Now let us look at an example of understanding what is a continuous random variable is. If you just look at the market share of a company, or the percentage of attrition among employees of an organization. Now, these are the numbers which will be continuous in nature. The market share of a company may range from ₹1 to infinite rupees over here. In the same way, the percent of an attrition may range from 1% to 100%. That means here, if you see here, you're going to have a continuous number. There's an infinite set of values, right? So hence, those such kind of variables which have the ability to take infinite values are called as continuous random variables. In many situations, what happens is, whenever we are going ahead with the machine learning or with the artificial intelligence application, we try to convert the continuous variable to a discrete variable for modeling. This we'll be discussing in detail in the further sessions while we are going to discuss about the machine learning algorithms. Till then, having an understanding of random and discrete variables and continuous variables, in the further session, we are going to discuss about what is a probability distribution, and what is a probability mass function, what is a probability density function. Till that particular point of time, please keep recalling the concepts of random variable, discrete random variable, continuous random variable, and see you in the next session. Till then, happy learning. Thank you. Welcome back. Now, as we know that random variables can be discrete and continuous, now we are going to discuss about what is a probability mass function with respect to whenever a random variable is discrete in nature and whenever a random variable is continuous in nature. Now, let us go and learn what is a probability mass function. The probability mass function for a discrete random variable is the probability that a random variable X taking a specific value. Hence, probability mass function is a function that maps each outcome of a random experiment to a probability. Now, to have a better understanding of what this probability mass function is, let us look at one particular example. Let us assume that a bank is looking for fraudulent transactions and the occurrence or the corresponding probabilities are being given over here. Now, if you see here in this particular table, the random variable here talks about the number of times the fraudulent transactions have taken place. So this is the number of times the fraudulent transactions have taken place. Now, if there is no fraudulent transaction, then the probability of occurrence of an event is 20%. One time fraudulent transaction, that is only one fraudulent transaction, the occurrence is around 15% probability. So if you see here, in all these particular 5 situations, the outcome of the each and every variable is being tied to the probability function over here. So that is called as a probability mass function. In this probability mass function, there are 2 conditions that are to be satisfied. To that, the probability of occurrence of an event should be always greater than or equal to 0. So if it is always greater than or equal to 0, then you can understand the occurrence of an event. For example, let us assume we wanted to study the fraudulent transaction. Now x1 is equal to 0 stands that there is no fraudulent transaction. Right? So hence, always the probability of occurrence of event should be greater than or equivalent to 1. And if you just sum up all the probabilities, the sum of all the probabilities should be 1. So this is about the probability mass function. Having an understanding of probability mass function for a discrete variable, now let us go and understand what is the cumulative distribution function. Now, cumulative distribution function is a probability that the random variable X takes less than or equal to one specific value. For example, if I just wanted to study the same example, banking example, if I just take about the assessing of fraudulent transactions, if I wanted to know the number of fraudulent transactions being less than 2 times, or equal to 2 times. Then how are we going to calculate the probability? The probability of an occurrence of event when there is no fraudulent transaction plus the probability of occurrence of event when there is only one fraudulent transaction, the probability of occurrence of event when there is at least 2 fraudulent transactions, because as we have mentioned, that is less than or equal to 2. Now, if you just look out this particular probabilities, 0.20 is the probability of non-fraudulent transaction, 0.15 and 0.25 respectively. So overall, if you just look at the function of the cumulative values at each and every event, it is coming to be 0.60. Now, in the same way, for example, if I just wanted to know the probability of occurrence of event less than or equivalent to 5 fraudulent transactions, then obviously my cumulative distribution function will take this particular form. So probability of an occurrence of event when there is no fraudulent transaction, so where occurrence of an event at least with 1, at least with 2, at least with 3, and at least with 4 now, and at last at least with 5. Now, adding all these probabilities together is going to give me the cumulative distribution function. So this is how the cumulative distribution functions are being calculated. So hence, in this particular session, we have studied about what is the probability mass function and what is the cumulative distribution function whenever your outcome variable is discrete in nature. In the further session, we are going to discuss about what is the probability density function and the cumulative density function whenever your outcome variable is continuous in nature. Till that particular point of time, have a happy learning and see you in the next session. Thank you one and all. Welcome back to the session on probability density function. Having an understanding of what is probability mass function and cumulative distribution function based on the discrete random variable, now we are going to learn about what is probability density function. Now let us go ahead and understand what is this probability density function. Whenever you have a continuous random variable which has the ability of taking infinite values, it is very difficult to measure because it takes infinite values over there. Sometimes to avoid this or to measure the continuous variable, we set an interval to this variable. For example, let us assume that the number of attrition rate or the times at which the percentage of employees are attriting from the company. Now, whenever I look at the percentage of employees attriting, so what I hear, this is from 1% to infinite percent, or we call it as 100%, right? Now, here what we do is we define an interval over here, saying that what is the probability that an employee attrites is around 1% to 5% probability, or 5% to 10% probability, or 10% to 15% probability, right? So this is how we divide the outcome of the continuous random variable into an interval which will be defined. Therefore, after having an understanding of this, how to measure the continuous random variable, if you just look out the definition of the probability density function, it is defined as the probability that the value of random variable x lies between infinitely small intervals, which are being defined as x1 plus delta x. Now, having an understanding of probability density function, now let us see how can we represent this. So hence probability density function reflects how dense is the likelihood of a continuous random variable is in infinitely small intervals around the value of x. Hence, the cumulative density function is defined as the function of an event where this particular event has the probability of occurrence of that particular event for less than a number of times, ranging from -infinity to a, which is a function of that particular event alone. So this is how we are going to define the cumulative density function. The cumulative density function gives you the area under probability density function whenever your outcome variable is clearly equal to a specific variable. That is, if your outcome variable x is clearly equal to x naught value, then what is the area that is being covered over here talks about the cumulative density function. So this is how cumulative density functions are being defined. Now, having an understanding of the cumulative density function and the probability density function, in the next session, we are going to discuss a very small example, which is called the binomial distribution. Till that particular point of time, happy learning, keep chanting the probability density and the probability mass function, then see you in the next session. Thank you very much.